In a bold announcement, scientists have disclosed a person's identity, a completely new realm, distinct from anything that has already been noted. NASA, famed for its groundbreaking studies, indicated that this recently observed astronomical phenomenon is captivating not just because of its size and course, but also because it emits signals that seem intentionally generated. Could this be huge? The discovery that we are on the verge of revealing information that could significantly reshape our perception of the entire world. Is this revelation true? Does it suggest the chance of alien life existing on planets beyond Earth? As we examine the astonishing findings of NASA, we could soon solve the puzzle surrounding these exceptional events. In 2007, the Dawn probe was launched by NASA to investigate some of the most fascinating bodies within the solar community. Propelled by 3 ion thrusters, Dawn set out on a mission that began with a 14-month investigation into Vesta, the second-largest small world in the asteroid belt. Dawn conveyed scientific data and detailed images, unveiling Vesta's intricate landscape and extensive geologic background. After completing Vesta's mission, Dawn made her way to what many considered the most thrilling aspect of its journey, an in-depth examination of the dwarf planet Ceres. Thanks to its ion propulsion system, Dawn was able to escape Vesta's pull, something impossible with standard chemical engines, and move toward Ceres. These thrusters accomplished gradual but sustained acceleration, allowing Dawn to travel far and wide and enter a stable Ceres-centered orbit. Ceres, first sighted in 1801 by astronomer Giuseppe Piazzi, is the largest object in the asteroid belt situated between Jupiter and Mars. For decades, it was seen as the smallest dwarf planet before its classification shifted in 2006. With an approximate 950 kilometers diameter, Ceres remains the heaviest object in the belt, making it one of the most intriguing celestial bodies due to its remarkable properties. Scientists eagerly awaited the first high-definition images of this enigmatic world, which revealed bright spots dispersed throughout its surface, especially within a large cavity referred to as a crater. These shiny regions immediately caught the attention of the scientific community. Prior to this, the only available images were low-resolution, blurry pictures taken by the Hubble Space Telescope, offering little insight. The possibility of sharper imagery increased optimism for revolutionary discoveries. The mission aimed to improve our understanding of the Sun, the beginnings of the solar system, and the role of water in shaping planetary bodies. The luminous spots, also found on other small celestial objects, were believed to contain materials with high reflectivity, possibly residual salts left after water had vanished. This implied the potential for cryovolcanism, a type of eruption involving icy volcanoes that release water or briny liquids instead of molten rock. The meaning of these glowing features and their contents remains unclear. Do they indicate ongoing internal activity? Or could they hint at something extraordinary? Ceres distinguishes itself from other asteroid belt objects through its weight, density, composition, and capacity to retain both water and ice. Unlike most rocky asteroids, its composition shows similarities to comets, implying that it may contain clues from the very beginning of the solar system's development. Following a 2-year journey, Dawn began its approach to Ceres in early 2015, a key moment as it prepared to deliver the first close-up images of the belt's largest structure. As the spacecraft got closer, it exposed a world previously concealed in the vastness of space. The initial images showed a battered surface marked by numerous impacts. But what truly intrigued experts and space enthusiasts alike were the glowing dots scattered across the otherwise subdued rocky terrain. As researchers analyzed the improved images, a number of potential explanations for the bright zones emerged. Might they be icy surfaces reflecting sunlight, or perhaps something far less ordinary? Theories ranged from mineral-rich layers to volcanic debris that had frozen. Further study revealed that the brightest region was actually a group of multiple shimmering areas rather than a single spot. The leading explanation suggested these were salt accumulations left behind after water or brine evaporated, implying that Ceres currently has or recently had internal systems capable of bringing water to the surface. These insights challenged the long-held conviction that Ceres was geologically inactive, instead presenting it as a lively and complex world. The possibility of underground saline deposits raises exciting questions about whether Ceres could contain the essential ingredients for life. Often referred to as an icy planet with a coarse yet absorbent shell, Ceres differs from most other small planets that are primarily composed of stone and metal. Its surface includes water, ice, clay-like elements, and carbonates, making it both lighter and chemically unique. This piece of writing points to a vast water reservoir. The outer layer is porous and holds volatile substances in a manner similar to comets rather than regular asteroids. Ceres, according to researchers, features a unique interior layout. A mantle that is semifluid and surrounds a central core with a lot of rock and ice. Most likely, the middle layer contains a mix of stone and salt water, enclosing a dense silicate at its core. The fact that such large quantities of ice exist indicates that liquid water may have been present, especially if heat was produced from early radioactive decay during Ceres formation. This extraordinary internal structure distinguishes Ceres from other inhabitants of the asteroid belt and raises significant questions about its geology and water's significance in forming celestial bodies. Additionally, the discovery of ammonia-based clays on Ceres suggests that it may have formed in the icy outermost regions of the solar system before migrating inward. Ammonia lowers water's freezing point, creating liquids that can flow close to or even at the surface. Not only do these observations broaden our knowledge of Ceres, but they also shape concepts regarding how other icy worlds in our solar system may have come into being. Cryovolcanism, a compelling and uncommon geological process, differs significantly from the fiery lava eruptions we observe on Earth. Ice volcanoes, or cryovolcanoes, eject liquids such as water, ammonia, or methane in frozen settings like Ceres. These substances can be released as gases or fluids. In particular, cryovolcanoes are thought to carry saline water with dissolved minerals to the surface, where exposure to space causes the liquids to vaporize rapidly, leaving behind traces of sparkling salt. This is a strong explanation for the bright areas captured by the Dawn spacecraft. The most obvious of these glimmering spots lies inside a crater, specifically within a region numbered SP5. SP5 attracted particular interest because of its extreme brightness and the observed shifts over time, likely as a result of occasional water emissions. This suggests that icy activity may still be happening or at least continued until quite recently. Beyond SP5, many other luminous areas are scattered across Ceres, each with its own distinct characteristics. The presence of cryovolcanism appears to be more common on Ceres than previously believed. These glowing features support the notion that Ceres is not a static relic, but rather a changing, evolving world. As Dawn continued to send data, numerous surface features were discovered. Craters of varying sizes covered the terrain, each marking an episode from Ceres' impact-heavy past. Every collision, whether from asteroids, comets, or other interstellar debris, tells part of Ceres' story and contributes to its layered identity in the larger history of the solar system. Furthermore, the presence of ammonia compounds on Ceres provides another important clue about its origin. Since ammonia slows the melting point of water, liquid water could have existed beneath or on Ceres' crust perhaps in ancient times, or maybe even today. This bolsters the theory that Ceres originated in the icy outer regions of the solar system before migrating inward. That migration might explain its unusual features, including its high concentration of ammonia and signs of cryovolcanic activity. As scientists continue probing Ceres' outer shell and internal composition, their findings impact our understanding of how planets evolve, where life might arise, and how geology works on frozen worlds far away. Once considered merely a cold leftover from the solar system's beginnings, Ceres has proven itself to be a fascinating planetary object, challenging outdated concepts and inspiring a new respect for what's possible within our celestial neighborhood. The Dawn mission, through its detailed and extended observations, played a crucial role in revealing these facts about Ceres. It produced the most comprehensive scientific and visual data ever gathered from this solitary dwarf planet. Dawn's legacy is essential to our comprehension of the solar system. Every signal from the spacecraft peeled away another layer of mystery, unveiling Ceres as a dynamic, living world long hidden from view. These advancements are just the beginning of an ongoing journey to decode the enigmas of the outer solar system. In the coming years, experts will undoubtedly continue examining the enormous data archive of Dawn, searching for additional signs of life-supporting conditions not only on Ceres but on other icy worlds as well. With progress in space exploration and the launch of new missions, even deeper discoveries may await. Can we eventually confirm more definite evidence of crystallization? Might we see more proof of underground water hiding beneath Ceres' icy exterior? Only time will provide the answers, but one truth is already evident: the saga of Ceres is far from over.